Ice and rain protection is provided for the airframe, the engine and propeller, the front windows, the pitot-static heads, and the angle of attack vanes in the Fokker 50. Electrical heating is used to provide ice and rain protection for the engines and propellers, front windows, pitot-static heads, and angle of attack vanes. Bleed air is supplied to the leading edges of the wing and tail section and to the engine intake to provide ice protection. Windscreen wipers are provided to remove rain from each front window in the cockpit. Bleed air is supplied by both engines to rubber boots in the leading edges of each wing and tail section to de-ice the airframe. Bleed air travels through ducting into two pressure-regulating valves which are located on both ice panels on the inboard side of each gear bay. The regulated bleed air is then supplied to 7 distribution valves. The distribution valves supply air to the de-icing boots. The distribution valves are located in front of the center wing, in front of the right outer wing, and left outer wing, and below the stabilizers. Both engines normally supply bleed air for the airframe de-icing system. However, one engine can supply sufficient air for the operation of the airframe de-icing system should an engine malfunction occur. Each distribution valve has 2 outlets that supply bleed air. Each outlet is connected to one of 2 de-icing boots. A cycle timer controls the time duration air is supplied from each distribution valve to a de-icing boot. The airframe de-icing controls and indicators are located on the ice protection panel at the overhead panel. The airframe de-icing controls on the ice protection panel are the airframe de-icing rotary selector, the manual de-icing selector, and the cycle timer fault and low pressure annunciators. The airframe de-icing rotary selector is used when operating in automatic mode of airframe de-icing. The selector switch has 3 operative positions. Off, which switches off automatic mode of airframe de-icing. Light, which automatically switches the airframe de-icing system on and off periodically. And heavy, which automatically switches the airframe de-icing system on continuously. Touch the airframe de-icing selector to confirm its position. The manual de-icing selector is used to switch on the manual mode of the de-icing system. The selector is spring-loaded to the off position. The switch must be held in either position 1 or position 2 to activate manual control. 2 fault annunciators are present on the airframe de-icing section of the ice protection panel. They are the amber timer fault light, which illuminates to enunciate that the cycle timer is inoperative, and the amber low pressure light, which illuminates to enunciate that the bleed air pressure is insufficient for normal operation of the airframe de-icing system. The airframe de-icing system is automatically operated provided the airframe de-icing selector is switched to the light position or the heavy position. The airframe de-icing system is initially switched to the light position when icing conditions are encountered. You see ice starting to form on the windscreen wipers. Take the corrective action. You have taken the correct action by setting the airframe de-icing selector to the light position. However, you find that ice continues to build. Take the appropriate action. Switching the airframe de-icing selector to the heavy position switches the airframe de-icing system to continuous operation. Setting the airframe de-icing selector is decided after studying the weather conditions. When a solenoid in each distributor valve is energized by the cycle timer, air pressure is applied to the associated de-icing boot. The boot is inflated and any ice on the boot is removed. After 7 seconds, the cycle timer de-energizes the solenoid. Air is sucked out of the tubes in the boot deflates and is held flat to the leading edges. A complete de-icing cycle, where all the boots have been inflated and deflated, takes about 1 minute. The de-icing cycle pauses for either 4 or 184 seconds between cycles, depending if heavy or light has been set on the de-icing selector. How long is the pause between de-icing cycles if the airframe de-icing selector is set to the heavy position? Yes. If the automatic airframe de-icing system fails, manual control of the de-icing system is available via the manual de-icing selector. Switch the manual de-icing selector switch to position 1. When the selector is held in position 1, bleed air is supplied simultaneously from distribution valve 1 to boot 1, distribution valves 2 and 3 to boot 3, distribution valves 4 and 5 to boot 5, distribution valves 6 and 7 to boot 7. Moving the selector to position 2 inflates boots 2, 4, 6 and 8 in the same manner. The selector must be held to position 1 or 2 for a minimum of 5 seconds. How long is the pause between de-icing cycles if the airframe de-icing selector is set to the heavy position? That's right. The amber timer fault annunciation is presented on the de-icing panel, indicating that the cycle timer is inoperative. A level 2 alert occurs. In these circumstances, the de-icing selector must be switched to the off position and manual procedure adopted. Take the corrective action. When the selector is set to the off position, de-icing can be carried out manually. Note that the timer fault light goes off. If the low pressure annunciator illuminates and a level 2 alert occurs, this indicates that there is insufficient bleed air pressure for normal operation of the ice protection system. The bleed air pressure can be increased by increasing engine power. The formation of ice on the propeller and spinner is prevented by electrical heating. Ice is prevented from forming on the engine intake by a combination of electrical heating and hot bleed air. The controls for the left and right engine anti-icing system are located on the engine anti-icing section of the ice protection control panel. Blank engine anti-ice push buttons indicate that the anti-icing system has not been switched on. switch the engine anti-icing system on. A blue ON annunciation indicates that you have switched on the respective engine's anti-icing systems. Two blue engine anti-icing lights located on the glare shield also illuminate when the engine anti-icing has been switched on at the ice protection panel. An amber fault annunciator is illuminated in the respective push button if an engine anti-icing system fails. What does the annunciation on this ice protection panel state? Yes. The engine anti-icing system automatically comes into operation if the total air temperature is below 5 Celsius, 41 Fahrenheit, provided the propeller speed is above 50% and the engine anti-icing push button is selected to the on position. Automatic operation of the anti-icing ceases if the total air temperature rises above 7 degrees Celsius, 44.6 degrees Fahrenheit. The temperature in the anti-icing control unit rises above 100 degrees Celsius, 212 degrees Fahrenheit. The propellers drop below 675 revolutions per minute, or the timer control fails. If a timer fails, all electrical heating is disabled. The leading edge of the air intake and part of the intake duct are heated continuously. The other surfaces in the intake and the propeller and spinner are heated periodically. Periodic heating of the intake, propeller and spinner is controlled by a cycle timer. The time period of heating is determined by the cycle timer and varies automatically depending on the ambient temperature. Part of the engine intake is heated with bleed air to supplement the electrical heating. Pressing the engine anti-icing push button to on opens a shut-off valve and automatically supplies bleed air to the engine inlet. On SAS commuter, the valves are locked in the open position. An engine anti-icing alert is presented if there is no air pressure when the engine anti-icing button is switched to the on position, if a fault is found in the heating of any surface in the engine inlet or propeller, or if the de-icing timer fails. Note, in SAS commuter, the air pressure is always on. Electrical power to the faulty surface is automatically switched off when a fault is detected in the heating of any surface. If a timer fails, all electrical heating is disabled. Engine anti-icing fault is indicated by a level 2 alert, together with a fault annunciation on the engine anti-icing push button. Each front window has a heating control unit and a temperature sensor. The heating control unit activates or deactivates heating of the front windows based on the actual window temperature signaled by the temperature sensors. The controls and indicators for window heating are located on the lower section of the ice protection panel. The controls and indicators are the window heat selector and the window heat push buttons. The three operative positions of the window heat selector are off, low, and high. Window heating is not provided when the window heat selector is switched to the off position. The window is heated slowly when the selector is set to the low position. The window is heated more quickly when the selector is set to the high position. Switch the window heat selector to the low position. The window heat push buttons are normally blank, indicating that the windows are heated according to the window heat selector position. An amber fault annunciation is presented if the respective window heat fails. A white off annunciation is presented on the push button if the window heating has been switched off. Please note if one push button is switched to the off position, window heating is switched off on that side only. Switch the left window heating off. Please touch the highlighted area. Please touch the highlighted area. That's right. The temperature sensors signal the actual window temperature to the control unit. If the temperature signaled by the sensors is below 32 degrees Celsius, 90 degrees Fahrenheit, a relay in the control unit is energized and the heating is switched on. The temperature increases until the window temperature is 54 degrees Celsius, 130 degrees Fahrenheit. When the temperature has reached 54 degrees Celsius, the relay in the control unit de-energizes and the heating is switched off. The window temperature decreases until it reaches 32 degrees Celsius, when the heating is switched on again. When would the window heating be switched on? That's right. Window heating is only provided when the window heat selector is switched to either the low or the high positions. Note, never switch the heating from off to high on a cold window, since this may result in the window cracking. There is a slower build-up of heat on the window when the window heat selector is set to the low position. There is a faster build-up of heat when selector is set to the high position. Selection of high or low mode does not affect the temperature that heats the windows. It only determines how quickly or slowly the window is heated. A check is performed by check units during the first 3 seconds when the window heat selector is switched to the low or the high position. The check simulates a low window temperature. Therefore, the relevant temperature control unit switches the window heating on. The check unit examines the current through the window element. If the current is out of limits, the check unit causes the amber fault annunciation in the push button to illuminate and a level 1 alert is presented. If this alert is presented, the push button must be pushed to the off position. This is the only time that this alert is presented. Electrical heating is provided to prevent the formation of ice on the pitot-static heads and the angle of attack vane. The controls and indicators for the probe heat system are located on the ice protection panel. The 4 pitot heat push buttons correspond to the 4 pitot tubes located on the front of the fuselage. The pitot heat push buttons are normally blank, indicating that heat is being applied to the pitot-static tubes. The amber in-op annunciator in the push button indicates that a heating element has failed in the pitot-static tube. A white off annunciator is presented on the push button if the system is manually switched off. An amber in-op annunciator is presented on the push button together with a white off annunciation if the parking brake has been released and the pitot heat has not been switched on. The vane heat push button is centrally located between the pitot heat push buttons. The vane heat push button is normally blank, indicating that vane heat is available while the aircraft is in flight. An amber fault annunciation is presented if a heating element fails in the angle of attack vane. A white off annunciation is presented if the system is manually switched off. The pitot-static tubes are automatically heated provided the push button that corresponds to the pitot tube is blank and electrical power is available. What does the probe heating section of this ice protection panel enunciate? That's right. Only the left-hand lower pitot tube remains heated by a battery when AC power is unavailable. The lower left pitot tube supplies information to Air Data Computer number 1. The angle of attack vane heater is operative whenever the aircraft is airborne and the vane push button on the ice protection panel is blank. The amber in-op annunciator in the push button indicates that a heating element has failed in the pitot-static tube. The pitot heat light is illuminated in the central annunciation panel together with a level 2 alert. An amber in-op annunciator is presented on the push button together with a white off annunciation and a level 1 alert if a pitot system is off after the parking brake has been released. A fault annunciation is presented in the vane heat push button together with a level 2 alert if the heater in the angle of attack vane fails. Rain is removed from the flight deck front windows by 2 wipers. The windscreen wipers are driven by a single 4-speed electric motor. The motor is operated by the wiper speed selector on the overhead panel. Note, on some aircraft, There are 2 wiper speed selectors, one for each pilot. The windscreen wipers operate in either full, 3/4, half, or low speeds. The selector is moved to the off position to turn the windscreen wipers off. The selector is moved to the park position to move the wipers to the park position. The selector will return to the off position under spring-loaded pressure when it is released.